start off with this chapter here. This chapter is about concepts in motion. So let's see if I could sort of like summarize what do I mean by this thing here. So what you're finding here, when I think about motion, okay, so if I say the word motion, I really see two pieces of this thing. And what I mean here is I really see the concepts, and then I see the mathematics. Now, my experience with this, with people at this level here, is that what you're going to find here is that the mathematics in this course is actually not that complicated. If you have had Math 5A or have already completed, higher up, the mathematics, for the most part, is somewhat trivial. Where everybody has the trouble is the concepts. And a lot of the people say, like, I understand everything, but I don't know which equation to use. Well, you've already lost as soon as you say that. Chapter 1 is about the concepts. And when you look at the concepts, what we're really trying to do here, when I say concepts, what I'm trying to do here is I want to describe the characteristics of motion. And the way we describe the characteristics of motion here is that means we got to look at its variables. I'm sorry, there's two pieces to it. One, we got to look at its variables. And the variables are displacement, time, velocity, and acceleration. And the other big piece to really conceptualize the motion here is what's called a motion diagram. And a motion diagram is a picture, and that picture in physics is everything. The vast majority of the time that I find when people were unable to solve the problem is because they couldn't draw the motion diagram. They missed all of the important pieces. And one of the most important pieces to mathematically solving problems in motion is getting the intervals. Finding out when you're moving at constant velocity or when you're speeding up or slowing down. Those details are quite important. And if you don't have those details, guess what? You're not going to get it. So what you want to do here is that you want to really focus on getting that picture in this chapter. It's the most important piece. Now, the second part is the mathematics, and this is what's called the kinematics. Kinematics is the mathematical study of motion. This is the equations. And from these equations, you're going to see that there are four main equations. And there's lots of ways that you can deal with these four equations. But in the next chapter, you're going to see that I have a fairly sophisticated way of actually getting the right equation. If you're really, paying attention and you're really doing the setup, you'll see that I'll organize you in such a way that you can always pick the right equation. There's no guessing. But again, the only way you get to the right equation is you got to start with the concepts. So this really tells me that I should probably tell you what is physics and what is mathematics. So typically, what we find here is that in physics, there's a physical picture of some phenomena. Okay, so the question is, what is the difference between physics and mathematics? Because a lot of times people think that, oh, physics is about the equation. If that's the way you think, you're very far from the truth. Okay? You're very far from the truth. So let's go look at that. So when I talk about physics, we typically are interested in something that interests us. And what I mean by this is that there's a physical picture of some phenomena. And what we do here is that we're interested in it. And what we try to do here is we try to analyze this thing as to what is physically happening. So typically, if we were in lecture, I would demonstrate it for you. But here, it's actually quite hard to demonstrate it because demos in this world is quite hard. And you'll see that the only demos that I do here are really little videos that I'll just click and say, okay, this is what I really want you to see, to get you to visualize it. But there's something that interests you. And this piece is what we call physics. So you're literally trying to get a physical picture of whatever the phenomena is going on. So as far as we are concerned in physics, that's the most important piece. And then what you find here is that there's sort of like a chain reaction. So from this physical picture, what we do here is then we describe the picture in terms of equations. We mathematically try to describe the picture in equations. So now we mathematically describe the picture in terms of behavior. In terms of the equations. So once we get this equation, what we do then is that we solve this equation, right? So the next piece here is that then we solve this equation to get the very important number. So the most important thing, as far as many students are concerned, is the number, right? You have a homework problem. You're going to solve something. Your whole goal is to get that number and then check it to the solution that I posted, right? And then if your solution is matches my solution, then you go like, okay, I got it right, and then you move on. But you got to remember, why is the number important, right? So the question that I'm asking, why is the number important? Well, the reason why it's important here is numbers are a universal language. And what I mean by that is that I could give you, a silly analogy. And my analogy here is that I want to compare two situations. And the analogy here is that you could imagine somebody calls me fat. What does that mean, right? I now know that there's two ways to spell fat. There's FAT versus PHAT. And when you look at this thing, this probably means what? Unexercised or whatever it is. And this one means that you're probably some cool guy, and here you might be, I don't know, thick. I'm not really sure in here, but I mean, you know which one I'm going to interpret, right? PHAT. And what you're finding here is that language is tricky. Language is very, very, very tricky. But numbers are not tricky, because if I give you a pin like this and I ask you, how long is this pin? And you take a tape measure, let's say that you measure a pencil / pin, and this thing here is, let's say it's 30 centimeters. If one person measures 30 centimeters, everybody else is going to measure 30 centimeters. So that 30 centimeters is the same no matter what. So numbers are important because they're a universal language. So when I say mathematics, this whole process here is mathematics. So when I look at this process here, as far as physics is concerned, we go like, yeah, we get a number, but wait a minute. If the number's right, then that means the equation that I derive from my picture is right. But wait a minute, where did I get that equation? It was from the picture that I started off with. So that number, that equation, is really about the picture. Without that picture, you can't solve the problem. That's the difference between physics and mathematics. Physics is the conceptualization of nature. And once you do that, we typically say all physics is done. So now what do? You start the crank. And what does the crank do? You generate an equation. From that equation, you generate a number. And if that number is wrong, you go back to the picture. That changes the equation. And you keep doing this. And we use this process called the scientific method. But that's the most important piece right there. So that's why when I come up here, I'm always interested in the concepts. That's the physics. And then we go into the mathematics, but I'm always going to start with the physical picture first. So I'm saying, so in your homework and in quizzes on exams, I'm going to say, draw me a picture. And if you don't draw me the picture, you know what I'm going to do? I'm going to immediately take points right away, immediately. And by the way, your sketch doesn't have to be beautiful. Or some people will refuse to draw a picture, and then what they'll do here is that they'll describe it in words. And that's okay too, because that means in your head, you have some picture. But in some shape or form, you have to describe the concept, the picture. That's what I mean by that. Okay, so what we're going to do here, in chapter 1, we're going to look at the concepts of motion. In chapter 2, we're going to look at the mathematics. In order to start to look at the concepts, of motion, let's make some simplifications. Why? Just to make it easier, that's why. And the first one here is that the first thing that we should do here is that we should always start off easy. So the easiest start is with straight line motion. And you're going to see that when I look at straight line motion, this is really chapters 1 and 2. And the straight line motion, sometimes you'll hear that it's going to be called one-dimensional motion. And then what you're going to find here is that then we're going to move on to 2 dimensions. So then we're then going to go on to 2-dimensional motion, and you're going to see what we're going to need here is that we're going to need vectors and 2-dimensional motion. So that means now we have to worry about this thing here. So what you're going to find here is that vectors, you're going to see, is chapter 3, and then chapter 4, which is this 2-dimensional motion. And what you're going to find here in 2-dimensional motion, it turns out that there's 2 kinds. There's what's called projectile motion, which is motion in X and Y, 2 dimensions. And then there's also this thing called rotational motion. And rotational motion also occurs in X and Y, but it might be convenient at this point to actually change coordinate system into what are known as polar coordinate system. Now, rotational motion we'll get to later on when we start to deal with what are called Newton's laws. So that's the first thing that we want to do. We start off with one-dimensional motion, which is chapters 1 and 2, and then we start getting ready for 2-dimensional motion, which is chapters 3 and 4. So that's the first thing that we want to do. The second thing here is that objects are called extended objects. And what I mean by an extended object is that, well, I mean, if you want to look at the motion of a car, note that the car has multiple pieces to it. And what I mean by that, there's the front of the car, there's the middle of the car, there's the back of the car. So objects, so when I look at a car here, you could imagine that if this is my car here, and it's moving in this direction, we don't want to talk about the front, the back, or the middle of the car. What we do here is that we replace the extended car with the center of mass location, which is a point. Okay, which is a point. So that means I'm going to take this car and I'm literally going to replace it with the dot that's then moving to the right like this. So I don't have to worry about those details then. So to understand motion is to understand, how do I say this? And then 3, to understand the concepts of motion is to understand and draw motion diagrams. Motion diagrams are a collection of dots. Okay? Motion diagram is a collection of dots. And so it's these dots that we really, really want to understand. So that's where I'm headed towards. It's these dots.